One of the scariest things I'm concerned about for America is that China wakes up and goes, you know what, we made a mistake. We need to allow Bitcoin mining. Now, China banned it for other reasons. Bitcoin itself is scary to China because China wants to control their currency, and they use their currency, they weaponize their currency, and they don't want Bitcoin to be a competitor to digital yuan. Bitcoin mining in China provided an inflow of Bitcoin to the Chinese economy.
When you roll back the clock and you look at the industry in 2018, it's a completely different industry than it is today. Also, as a quick thank you for listening to this channel, we have a link in the description for the viewers that will give you access to Saz Mining's team and any other promotions that Saz Mining is running. So if you want to get exposure to Bitcoin in the best way possible and at a discount through Bitcoin mining, then make sure you click on that link in the description. You'll get the opportunity through Saz Mining. Back to the show. So Russell, thank you so much for taking the time to join me on this discussion here. You're one of my very early podcast guests when the Saz Mining podcast first started. It was one of my favorite conversations. I've had the opportunity to speak with you a couple of times since. And so I just wanted to first off say thank you for coming on the show once again.
Appreciate it. Thank you for having me back. I'm looking forward to it.
So for this discussion, I was thinking we could touch on a number of big topics related to the New York Times hit piece, what's happening in Texas, views on regulation and all over the industry. But then also, I think you're the best person in the entire industry to talk to when it comes to understanding fleet optimization, understanding the energy side of Bitcoin mining, understanding how the hardware side looks today and where it's going in the future. So we'll touch on those as well throughout the discussion. But before diving into all that, maybe if you could just give a quick 1 to 2 minute background on how you got into Bitcoin mining and where your expertise lies.
Okay, very briefly. So I first got into Bitcoin in 2014. I first got into Bitcoin mining in 2017. And I was friends with Darren Feinstein, who's one of the founders of Core, when he had started what was Core's predecessor. And in late 17, the very first month of 2018, I sold my mining company at the time, mostly Ethereum based though, to what was Core's predecessor. And me and that whole team joined Core. And almost lock, stock, and barrel, we're all still there from that very early group. And that whole team and I, we've been part of Core ever since, even Core's predecessor, as I said, then became Core Scientific. So the background previous to that was all tech related and tech companies. But ever since then, I've been at Core. So it's been great. It's been a lot of fun.
So Core is one of the massive mining companies in the industry. Whenever people think about Bitcoin mining and start looking into Bitcoin mining, Core is one of the companies that is just front and center. You guys are buying a tremendous amount of power. You've mined at extremely large industrial scale. So when you take a step back and look at how you actually achieve this engineering feat, what do you think goes into it that a lot of people don't necessarily understand?
So, first off, it is interesting. You know, last year, our facilities, we mined over 26,000 Bitcoin, which is a lot. That's a lot of Bitcoin. And, you know, the interesting thing is, and I had people talk about or ask me questions about getting started in mining, and the difference between home mining and mining 2 or 3 megawatts worth of machines, mining 200 or 300 machines versus 2 or 3,000 machines versus 10,000 machines versus 200 or 300,000 machines, the engineering that goes into it is just dramatically different. And anyone wanting to get into mining, I highly advise you to start small because you can really make mistakes. There's a engineering management side from the thermodynamics, the heat, the power dissipation, the heat dissipation. And then of course there's a software side of actually, of these machines coming on and off and in repair and those kind of things. So I think, as we've grown over the years, when you first start out as a small company, you have to have a lot of people, have to wear a lot of hats. But as you get to industrial scale mining, there's some specialization involved. And at Core, we have that. We're not a huge company. We have, 300-ish employees. Probably 200 of them are direct data center technicians and engineers that work in the data centers. But we do have a team of software engineers, a team of hardware engineers. We have facility design engineers that specialize in both thermodynamics and electrical. management. So all those things, as you become a large industrial miner, you have to keep aware of. And then outside of that, and something we're going to talk about, is just the effect on the grid. When you're mining 2 or 3 megawatts, it's not a huge effect on the grid. But when you're mining hundreds of megawatts in one location, that's a grid management issue. So you don't just buy power from the local power company. You're actually talking to them pretty regularly, and you talk to them from the very beginning when you're designing your facility all the way through. We have a power team. We actually have a full team of folks that just manage the power, and they're talking to the utility providers on a daily or weekly basis, just as part of our overall fleet management of the power usage we have.
So on that point of the power side and communicating with, or I guess the better way to think about it is just coordinating all of this. At what stage of power do you need to start getting into that level of detail where you're really in that constant of communication with the energy side? And then how has that relationship evolved over time?
So, if you are only mining 2 or 3 megawatts, you're probably just going to be buying off the rate card, and you're really not going to have a huge impact on your local grid. A super Walmart, has a 1.5 megawatt, has a 2 megawatt transformer out front. So just to give you an idea, that's kind of like just a big shopping center. And that's something that the local power grid can handle. When you start getting 10 or 20 megawatts, the power company's going to know how much you're using. If you're looking at a 50 megawatt site, that's a substation. And that is something that, unless you've talked to the power company ahead of time, there's going to be problems. And when you're talking a 100 megawatt site, a 200 megawatt site, a 300 megawatt site, you're actually having conversations well before you're even, purchasing the dirt and building your substation, because that's going to have an effect on the generation side. What we do at Core is we actually talk to the power providers about underutilized generation and underutilized transportation on the grid, because, and we'll talk about this later, I'm sure, but Bitcoin mining has certain aspects of it that can be beneficial to the grid if it's placed in the appropriate spot. So at Core, because we do operate at such a large scale, we go in and talk to the power companies first, and we talk to them about their generation and about their footprint and about where they have overflow of power, to put it in an easy term, where they have generation and where they have transportation that's not in use or underutilized. And that's super important. But if you're only a 2 or 3 megawatt miner, or you're mining with GPUs, you can really do that without a big effect. But you start getting above that, and you really start needing to talk to people.
Yeah, like when you roll back the clock and you look at the industry in 2018, it's a completely different industry than it is today. I remember in those earlier days, you didn't have many of these extremely large facilities. You didn't have facilities like the ones that Core and some of these other large public miners are running today. And you also just didn't have an energy sector that was proficient in their understanding of Bitcoin mining. Those conversations that you would have with the utility companies, a lot of it was just explaining how exactly Bitcoin mining worked. So my question for you here is that now that we've seen this evolution of Bitcoin mining, where do you think the energy companies are at today in their headspace towards understanding Bitcoin mining, as well as their approach towards it as a industry versus any other industry?
So, that's a great question, actually. At Core, our oldest facility is in Marble, North Carolina. It's still one of my favorite facilities. I love that little valley. The weather's awesome. The team there is great. But an interesting thing there is that we are provided power there from both Duke Power and TVA. And Duke and TVA are some of the oldest and largest providers in North America. And when we first started operating there, there was a lot of explanation. There was a lot of folks that on the power side that didn't understand. And quite frankly, on the mining side, we didn't understand the flexibility that we provided to the energy grid. Just because we didn't know. No one did. I actually think that facility is probably the first large-scale industrial mining facility in North America. At the time, there was large-scale facilities in China, but they were operating under cover of darkness. And that's not really the right term, but they weren't necessarily operating and sharing their information with the world. And they certainly weren't sharing their information with their power grid in China. So here in the States, when we first opened up that first large-scale facility, it was the first one. And no one really understood the flexibility that our load as a Bitcoin miner has on the grid. So again, as we first opened up, there was a lot of questions. If you look back now, though, 5 or 6 years on, I think both TVA and Duke Power are both fans of mining companies. And quite frankly, those power companies that have had a large-scale Bitcoin miner for a while, they learn the flexibility that a miner can bring to the grid. I think those power providers that have been with us for a while, if we went to them and said, hey, we want to expand, can you tell us another place where you have excess generation, or you have another facility that has excess transportation, or you have an underutilized substation, I think they would happily sit down and say, okay, let's look at our map together and talk about it. Because over the years, the power companies, at least the utility providers, those responsible for the grid, have really embraced what can happen with Bitcoin mining. Now, I'm sure we'll talk about this, but in Texas, ERCOT got a little scared because they got overwhelmed by requests. But I think those mines that are open up in Texas, and we might talk about this later too, but those miners that are open in Texas, we had a winter storm there back Christmas of this year, and they all curtailed, and that really, in a positive way, affected the ERCOT grid as compared to two winters ago, when much of Texas was without power for a long time. We can go into details on that later, but I say that to say that the more experience your large-scale utility providers have with Bitcoin miners, and I mean industrial-scale Bitcoin miners, I think the better they are at supporting us, and then the benefits they see for Bitcoin mining.
Yeah, right now it seems like there are 3 key topics that all converge on the New York Times piece and what happened in Texas with Winter Storm Uri. And it all ties back to demand response in a big way. And so first, before diving into some of these positive attributes of Bitcoin, or actually, you know what? I think what would actually work best is let's first dive into the positive attributes of Bitcoin mining. And then from there, we can talk about demand response and then go into the New York Times piece and then Winter Storm Uri. So just clean slate. When you're talking with these energy providers, you've noticed that over time, Bitcoin mining provides a lot of benefits to the energy sector, to the grid. What are those benefits, and why is Bitcoin mining the silver bullet versus these other industries?
Yeah. So interesting thing. So when you look at Bitcoin mining, we build data processing centers. And the difference between a traditional data center, and my background is data centers, our head of ops, Matt Brown, his background is data centers. At Core, we have a lot of folks who have a background in data centers. Data centers store data, and you, the user, you're going to use your Visa card. You're going to be able to access that database, access your bank account to make sure you can use that Visa card. So data is stored and data is accessed, and it needs to be available 24/7. And that's important because it means a traditional data center can never be without power. It needs power all the time, 24/7, 365, so that all that data can be accessed. Bitcoin mining doesn't store data. It processes data, and it processes data across a distributed network. That means if my data center is down, all the Bitcoin processing goes to your data center, but it still is processed. Now, you or I, if we have a Bitcoin mining, we are paid for the process that we provide, but if we're not providing the process, we're just simply not paid. It doesn't mean that a Bitcoin network is down. So that one big change there between a traditional data center and a Bitcoin mining data center means that there's a flexible load for Bitcoin mining. It also, though, Bitcoin miners, unlike traditional data centers, really are location agnostic. Our machines do most of the work. You do have a small and dedicated workforce at your data centers, but unlike traditional data centers that like to be located near population centers, so that the software engineers and folks can always constantly be coming in there and updating their hardware and changing things, and they need to be very close to high-speed internet so that you, the user, can access your data that's stored there. A Bitcoin mining data center is location agnostic, and the amount of bandwidth we need, though it needs to be constant and consistent, it doesn't need to be a whole lot. So that means that we as Bitcoin miners can be located just about anywhere, and you can turn us off just about any time you need to. And those two key characteristics are things that, when you dive into the details of it, make us very interesting for utility providers, because what it allows utility providers to do is talk to us and say, hey, look, we've got generation or we've got transportation, and it's located here in this town and it's underutilized. And it might be underutilized because back in the 60s, it was a large manufacturing base there, and that manufacturing base has now moved, but they still have the generation there. They still have the transportation there. And that's a key component there, because we can go and sit down in that facility and start utilizing that generation and that transportation. And I'm going to back up a minute and say why generation is important, because, and people understand electric grid, understand this, but some of your listeners might not. Power, when it's generated, it takes power to move power. It takes electricity to move energy. Or so I should say it takes energy to move electricity. So whenever you generate power, it's local. It needs to be used locally. And the more miles away from that generation you have to push that power to get to the end user, that power degrades over time. So it takes power to move electricity. So if I generate 100 megawatts of power, but I have to take it 1,000 miles away, I'm only going to have 2 megawatts by the time I get there. So because it takes power to move power. And that's a real key important component here, because it means when power companies have generation, if you can locate a Bitcoin mine close to that generation, it's highly efficient. It's very efficient, and power doesn't go wasted. And if you talk about being efficient and being sustainable, what you want is every piece of fuel, that, whether that's sun, hydro, nuclear, natural gas, whatever the fuel is, when that fuel goes into creating power, you want that power to be used, because if it's not used, it's wasted. And that's inefficient. That's not very good sustainable piece. So Bitcoin miners being close to the generation is hugely important. And then your second piece, and what's very expensive, is the transportation piece. In Texas, the biggest issue in Texas is most of your power generation is on the west side of Texas, but most of your population is on the east side of Texas. China has the same problem. Most of its power is located in what we would call, if we were looking at a map of the United States and a map of China, most of its power is located in Seattle, but most of its population lives in Miami. And that's a long way to move all that, because China has a ton of hydropower, but it's so far away from their population centers, and that's an issue. So with Bitcoin miners, because transportation is expensive. Just to give you a rule of thumb today, it's about $1 million a mile to move high speed or high end electricity. $1 million a mile. So just think about that. Substations where you actually do the distributions. You're $100,000 a megawatt to build just the substation right now in the United States. And that's if you're building a lot of them. At Core, we build a lot of them. You talk to your local utility company who builds one every 5 or 6 years, they're going to tell you it's $250,000 a megawatt. Because they're just not used to building that many of them. So, when you talk to a utility company and you say, look, we can go beside your generation, we can go beside that nuclear plant that's underutilized, we can go beside that hydro plant that's underutilized. Those are key attributes that a utility company says, wait a minute, we can actually sell this power that's right now being wasted or right now going into the ground, and we could take that money from selling that power and we can use that to reinvest into the grid. And that's another huge key attribute, is taking wasted power or underutilized power and paying a power company for it. And that's something else I'm sure we'll talk about as far as investing in the grid. But keep going on.
Well, that was a beautiful explanation that dove into the weeds of a lot of these talking points that we hear within the Bitcoin mining industry, right? One of the big ones, Bitcoin mining helps make use of underutilized power assets. And I think you gave a great example there. Let's say that you were back in time and there was a steel mill in some more remote location that's no longer operating there. Well, they still had all that power generation capacity at that location, and it's not economical or just being wasted because they can't transport it or afford to transport it $1 million a mile. So you go, you plop some Bitcoin mining down on site, and now all of a sudden you've got that asset that was not being effective, not generating any cash flow, not being utilized, to actually start generating economic value and processing data, as you mentioned, for the Bitcoin network.
We have two key examples of that at Core. One being the Marble facility, which was an old textile facility. And it was shuttered during NAFTA. Some of that moved offshore. That facility sat dormant for a decade. And in that town, in Marble, it's a beautiful little town. It's only got 300 people live there. The whole county only has a couple thousand. We employ, probably 75 people there sometimes. So it's amazing to see that happen. And we do it again in Kentucky, Calvert City, Kentucky, outside of Paducah, is a former smelting plant. Again, when you have a smelting plant in industrial America, it took a lot of power, which is why, by the way, if you look, former Alcoa sites are big mining operations now. But smelting plants took a lot of power. So there was a lot of generation and a lot of transportation, a lot of substations built by there. But then as America moved away from that kind of industrial base, those facilities were abandoned. And when you look at environmental impact, if you could take something that we've already paid for and we've already, built, and reutilize it and use it again, then as far as sustainability goes, you're checking a lot of boxes.
Yeah. Imagine if every single time you took a flight, the plane was obliterated. That was the big thing with rockets. I think that Elon Musk was talking about this, that you can take the cost of space travel down a significant amount if you could just continue to use the rockets to get there and back, kind of like you do with airplanes. It gets very uneconomical if you have to scrap it every single time. It's not a perfect analogy, but the analogy here would be, look, we've already put all the energy and force and human labor and capital into creating this power generation. Why just let it go to waste and go do something else when we can actually utilize this and keep creating value from it?
So think about, this is exactly right, Will. Think about a nuclear plant or a hydro plant that has been built. So we built a lot of hydro in this country back 70, 80 years ago. We thought those dams were going to last for 20 or 30 years, and they're still just operating at fantastically. If there's an underutilized hydro plant, it's actually better for those turbines to run and produce the power and for us to dissipate the power into the ground. So think about that. We're creating power and dissipating it into the ground. Now, the alternative, though, I give you is we can come locate a Bitcoin mine near that hydro dam, i.e., this is what we do at Marble, because we're near 2 hydro dams. And instead of that power going into the ground, we're actually paying TVA for it. We're paying Duke for it. And both TVA and Duke are regulated by how much money they can actually give to their shareholders. The rest of it has to go into the grid. So think about that. At both locations, we're buying power from those power companies that would otherwise be dissipated into the ground. And then in both instances, they're regulated. So 7 or 8% actually makes it to shareholders, not TVAs, because the shareholders are the federal government, of course, you and I, the taxpayer. But for Duke, 7 or 8% makes it to the shareholders. But all the other money that we give them, they have to invest in the grid. And if you drive around Cherokee County, you will see that in the form of new transportation. And why that's important is that new transportation they're building, when you take and you go in and you replace your transportation that's 70 years old and you put new stuff in, guess what's improved over 50 years? The engineering of it. So that is more efficient. That means the whole grid is more efficient. The whole grid is going to have higher uptime. So when you take a Bitcoin mining company and you set it down beside underutilized generation that would normally be dissipated, and we're paying for that power, when we give that money to the utility company, I can't stress this enough, most of that excess money has to go back into the grid and is improving the overall electrical infrastructure of our entire country. The same thing for a nuclear plant. When you fire up a nuke plant, and we're doing one right now in Augusta, Georgia, Southern Company, along with several of the partners, are turning on the first new nuclear power plant in America in 30 years. But when you fire up those things and you start degrading that uranium, once you start it up, you can't stop it. You have to use that power. Now, in Georgia, they're going to have no issue using that power because Atlanta takes a lot of air conditions. But when you look at nuclear plants around the country that are underutilized, Bitcoin miners can go in and say, look, you're underutilizing and you're dissipating 300 megawatts into the ground there. Tell you what, we'll put a Bitcoin mine right here beside you. We'll buy that 300 megs worth of power from you. It'll be cheap. But what that allows you to do is we'll buy that 300 megs from you, and all that money goes into the grid and improves and makes our own grid for the whole country more resilient overall.
I'm so happy that you flushed out that point as well, because that is one of the big takeaways of why Bitcoin mining is so amazing for the energy sector, is because now these companies have the ability to go and invest in the grid. I mean, we think about it like we can just wave a magic wand and stuff gets built. But at the end of the day, this takes time, this takes energy, this takes money. And you can't just snap your fingers and have a windmill up and running tomorrow, right? And so Bitcoin miners are making the economics for these energy companies much better and allowing them to invest in the grid and make it more efficient.
Yeah, I'll even make one more point, since this is a long form format here. And that is, Bitcoin miners allow utility companies to increase their base load. What I mean by base load is, if you're a utility operator, you're a grid operator, you have to figure out how much power you need to run the town's going to use. The town you're responsible for, you got to figure out how much power they're going to use. But if that town's, say, in the south, then what we think about is, hey, in July and August, I need a little bit more power because of the air conditions. And you have two options when you're a utility grid operator. That is, you have your base load and your if you increase your base load, you might have it up to 1,000 megawatts for your whole grid you're operating, but you're only using 900 for most of the year, and then you're using the other 100 you're using just for those summer months when it's really hot. So you're wasting that other 100. So it's very inefficient. So another option is you decrease your base load, and then those 2 months out of the year, you're buying off what's called peaker plants. And peaker plants are inefficient because peaker plants are your dirtiest plants. Not because when they operate, they're inefficient, but the turning on and turning off process is inefficient. So if you want to look at the dirtiest time power is generated is not when it's running. Because when it's running, power companies want plants to be very efficient. They want to burn all the fuel, no matter what that fuel is, whether it's natural gas, coal, whatever it is. They want it to run and be as efficient as possible because that's how they make profit. But when you turn it on and turn it off, it's inefficient. It's like a gas grill. When you turn on a gas grill, you turn it on, gas is escaping, you light it up. And then when it's running, though, it's good. And when you close it, that's when you heat your burgers. Because when you close it, all that heat stays inside. When you turn it off, you open it up, all the heat escapes, all the gas escapes, and you turn it off. But when it's closed and it's running, all the fuel's being burnt and it's all being converted to heat and it's all cooking your burgers. So think about a natural gas plant like that and think about a peaker plant like that. What Bitcoin miners allow a utility operator to do is to increase their base load all the way to that 1,000 megawatts. And then in the heat of the summer, when they need that extra 100 megawatts for the air condition, Bitcoin miners can turn off and the power company can take that 100 megawatts from the Bitcoin miner and feed it to the air conditioners. So Bitcoin miners allow the utility grid to increase their base load, turn us off, curtail us when they need it, but avoid the use of peaker plants. And that's another key attribute, is that we allow that increase of base load and the avoidance of peaker plants. Peaker plants are expensive and they're dirty. So that's another key attribute that Bitcoin miners provide a utility grid, is increasing base load.
That's a perfect segue into what's happening in Texas. So in Texas, we're seeing legislation moving forward that is going to limit the Bitcoin miners' ability to help in this type of a way, to participate in demand response programs. And one of the things that we've seen in response is that they're pushing forth peaker plants once more in Texas. So what are your thoughts on everything that's happening in Texas regarding the legislation, regarding peaker plants? And then maybe we can go later on in the discussion to some predictions for the future of the mining industry.
So I think what's happening, and I can't speak for the Texas legislators, probably much like South Carolina legislators. As individuals, they're great people. When they get together, though, they make stupid decisions sometimes. I think if you dive into it, the folks that are pushing that are actually not talking to their grid operators. I think they're not talking to their folks at ERCOT that just got to experience what they wanted to experience at Christmas time here when that winter storm came through, because the winter storm came through Texas, came through actually most of the country. Bitcoin miners, everybody else turned off. All that power that was being generated at a base load went right to the grid. It did exactly what it's supposed to do. And I think what's happened here is that experience is probably sitting in the minds of your ERCOT guys and your engineers that are responsible for the grid. But that happened in relative terms very, very recently. And that information has not gotten to the Texas legislators. And the Texas legislators that are trying to pass this bill don't have an understanding of the benefits that mining adds to the grid. Texas is going to have a problem that the United States is having, and it's that other people are going to figure out just how beneficial it is to the grid. And if Texas runs folks off, they're going to go to other states that have figured out how beneficial it is. And those states are going to say, you know what, this is good for the grid. And the U.S. is going to have that problem. There are other countries right now that are looking at these positive attributes of Bitcoin mining and saying, wait a minute, we can use Bitcoin mining to actually fund investment in our infrastructure, in our utility infrastructure. So there's other countries in the world that are right now courting Bitcoin mining in a major way because of those quality attributes that Bitcoin mining has, because they go, look, these Bitcoin miners will buy our excess power, and all that money can pay for infrastructure improvements. In the United States, if we drive away Bitcoin mining, that's exactly what's going to happen. Other folks are going to raise their hand and go, we'll take all those quality attributes. And the same thing's going to happen in Texas. Bitcoin miners went to Texas because there was generation there was flexible load there, and there was some economic benefit to participating in a flexible load. If Texas sees that there's too many people benefiting from flexible load, they just need to adjust the economics of it for everybody, not just Bitcoin miners. Just say, look, we only need 2 gigs of flexible load, and here's what we're going to pay for. So Bitcoin mining doesn't need to be targeted in Texas. They just need to let their ERCOT folks tell them how much of a load they want to pay for, and keep the economics the same for everybody, because it's just economics, and business will go where the economics works. So the positive attributes of Bitcoin mining, I think that ERCOT, the engineers, are seeing versus what the legislators think or have not gotten in balance yet. Hopefully this does not pass. Texas legislation only meets every 2 years. And in that 2-year time frame, there'll be some education that goes back and forth between the engineering side of the operations and the legislative side.
For anyone listening, they can tell from the conversation up until this point that these are not simple concepts, right? And not every single person out there who's making decisions on our industry necessarily have the time to be able to dive in and understand everything related to how the energy grid works, how Bitcoin mining works. And this recent New York Times hit piece, did you have a chance to read this piece?
I read most of it, and it was almost
it was a long piece. And what was most frustrating about it was that it was, if you just tried listening to it, it's a 27-minute listen. It's a very, very long piece, and it's only presenting one side of select cherry-picked facts and then spinning a narrative with it. And in the end, it was trying to paint demand response that these Bitcoin miners were doing as if they were greedy and stealing money from the ratepayers on the grid and taking this electricity that was potentially killing people out in Texas during this winter storm. It's like, no, the storm led to these power generation assets that had to go down, that couldn't function, and the miners helped by bringing electrical by helping support the electrical grid in Texas. And so someone might just read that and then all of a sudden think, okay, well, Bitcoin mining equals bad and they should be shut down and this legislation should pass and Bitcoin miners shouldn't be able to participate in demand response, which is just absolutely ridiculous. So if you had the ears of the politicians right now and you were just trying to educate them, let's say that they're either watching this or they ideally would be speaking to the actual grid operators in Texas, what would be just a key, easy take-home message that they could leave with from this discussion?
The easiest thing is this is just a mispricing. This is just an economic mispricing that is happening right now. In Texas, ERCOT, the engineers that operate the grid, they have decided how many gigawatts of power that they need in demand response. And what I mean by that is that base load we talked about. In Texas, they want to increase their base load, but they need enough that they can curtail on demand in order to increase their base load to lower the peaker plant demands. So what Texas has done, what ERCOT has said is, here's how much we put in the base load. And by the way, without Bitcoin mining, the economics or the amount of dollars required to convince someone to turn their power off was very high. Because think about this, if you're a car manufacturer and you have 6,000 employees coming in and you're expected to make 3,000 cars a week, and the power company comes to you and says, hey, I need you to turn off for a week and I'm going to give you $4 to do that. You're saying, dude, I've got $100 million worth of cars I got to get out the door this week. You're not going to give me $4 and have me turn my power off. So they said, oh, we'll give you $25 million to turn your power off. Well, we're getting kind of close, but I still got $100 million worth of cars going out. So it's just an economics and a pricing thing. Now what's happened is Bitcoin mining comes in and says, we actually have attributes where we can turn off and turn on, you know, in 5-minute intervals, 15-minute intervals. We can make that work. We'll take your money. Okay. We'll buy all your power 24/7, 365. But when you need to turn off, we'll turn off for that. What's happened is more Bitcoin miners have come in. So all that really needs to happen is ERCOT needs to adjust their pricing to say, okay, well, now that we have more people that are willing to turn off like this, here's what we'll pay. And that it is typical capitalism. It will correct itself. ERCOT just needs to say, here's how much demand response we need. We need 2 gigs worth. And then let the market bid on what that pricing is going to be. You don't need to shoot Bitcoin miners, because Bitcoin miners actually help drive down the price of that demand response and the cost of that demand response. It's actually good for the grid, because if Bitcoin miners left, it goes back to you're trying to turn that car manufacturer off and it's going to cost you a lot of money to do that. So if I had anyone to say, I would say, look, this is typical capitalism and typical economics. Let the market correct itself. Let ERCOT and your engineers decide how much they need in demand response. Let the market decide what it's worth, and take advantage of. Don't push it away. Take advantage of those attributes of Bitcoin mining that will lower the cost of demand response for your overall grid and be an economic benefit for the citizens of Texas.
Let's imagine that you're a Bitcoin miner. If you're listening, imagine you're a Bitcoin miner and you're trying to run the best business possible. Well, you've got a lot of decisions to make. One, you want to be in a place where you can operate your business. You don't want to be a miner in China when they shut down and ban Bitcoin mining. But you also want to make sure that you're as profitable as possible just from the economics of your business. And so I love what you say when you say, just let the free market do what it can do and improve the energy grid. And with Bitcoin miners, what are the economics? Well, it's going to take you a certain amount to acquire all the hardware, operate and mine Bitcoin. And if you can operate more efficiently, if you can get cheaper cost energy, if you can optimize all areas of your business, your cost per Bitcoin minted is going to be much lower. And I think that for people listening, getting to hear from you, someone who's operating Bitcoin mines at the largest scale and realizing, hey, demand response is an important piece. When you're going and you're looking where to put a facility, or when you're looking to go and optimize your mining operations, this is a big decision point. And at the end of the day, it would be a shame to see regulators in the US be making a misstep like the people in China when they tried to ban the industry. Not necessarily saying we're doing that right now, but these are decisions that have ramifications for the decision makers of you as a Bitcoin miner. Why would you go and mine in Texas if you can't participate in demand response when you can go and mine in some other state that has a very favorable demand response program that maybe gives you some type of economic development incentive, some tax incentive? You're much more likely to go and hire people in that area, support their demand response program, lower the cost of and increase the efficiency of their grid. And these are decisions that politicians are going to have to make on behalf of the people that they represent. And I just hope that they take the time to learn about it and ideally not ban free market capitalism from improving their city, town, electrical grid.
I'll tell you this, if you are a local politician and you have a small town that once had an industrial base and you are a utility provider that has excess generation or excess transportation and you have some abandoned facilities, you should recruit Bitcoin miners because they're going to come in, they're going to rehab the building, they're going to make a capital investment in the property, and then they're going to bring good paying jobs. And they're not going to replace the 6,000 people that used to work at the car plant, but the 50 or 60 folks they're going to hire are going to be just fantastically paid. They're going to like their jobs, and they can stay in a small town. They don't have to move away. We hire a lot of kids right out of high school in the small towns, and a lot of times they would love to stay in the town they were born and raised in, but they have to leave to go find jobs. Well, we provide some of those good paying jobs. We really do. And folks at Core in our data centers, they normally like to come in and stay for a long time. Of course, we have plenty of competitors trying to recruit them all the time because our folks are well trained. But if you have those kind of attributes in your town, you should look to Bitcoin mining, especially if you're a grid operator. If you're a small co-op operator and you have an extra 20 megawatts that you would level on your base load, you should recruit Bitcoin miners because it's really good for the grid. And I want to go back. You mentioned China. One of the scariest things I'm concerned about for America is that China wakes up and goes, you know what? We made a mistake. We need to allow Bitcoin mining. Now, China banned it for other reasons. China has their own digital currency, and they were trying to ban the use of Bitcoin mining because Bitcoin itself is scary to China because China wants to control their currency, and they use their currency. They weaponize their currency. Rightly so. It's their prerogative to do so, but they've weaponized their currency. They've weaponized the digital yuan, and they don't want Bitcoin to be a competitor to digital yuan. And Bitcoin mining in China provided an inflow of Bitcoin to the Chinese economy. And that's why they banned Bitcoin mining. If they weren't trying to ban Bitcoin itself, they wouldn't have banned Bitcoin mining because of all those attributes to the grid. But the scariest thing for me is China wakes up and says, you know what? We're actually okay with Bitcoin. We're going to let Bitcoin mining start again because it's good for the grid, because all of a sudden, America and North America then has a heavy competitor for Bitcoin mining, and China could embrace that again, and it'd be a seismic move for those folks in North America.
That's a very good point. I actually hadn't even thought about how China, if they reverse their decision, that would have huge ramifications. I mean, there's already been massive black market for Bitcoin mining arise in China. And it's been an interesting case study that even if you try and ban something, it's really, really hard, especially with something that's decentralized like Bitcoin mining, to completely erase it if people want to continue to operate.
If China did something as simple as, so China fixes their own currency and they fix their digital yuan, but if they decided they wanted to use Bitcoin as a basis with an exchange rate against their digital yuan, if China woke up one day and the party there decided they wanted to embrace Bitcoin and use it as an exchange for the digital yuan, and all of a sudden the digital yuan and Bitcoin had an exchange ratio and could come in and out of it, China could decide to do that, and it would be smart for China to do. But it would also, again, it would lead a lot of Bitcoin mining there. Bitcoin mining would be suppressed in other parts of the world because China does have that. Like I said, they built out all that hydro base. So they do have a lot of inexpensive, clean, renewable power. And it would be a seismic shift. It would be a black swan event.
So on the topic of fleet optimization, we've talked about at a high level some of these different areas of trying to get the cheapest energy, trying to maximize things like demand response, and then the difficult challenges that you have in terms of scaling up an operation. But from your perspective, taking everything that you've learned over your years within the Bitcoin mining industry, how do you assess profitability? How do you go about saying, okay, well, we want to build the best operations possible? How do you go about assessing sites? Because you've got this global industry where you can be mining in the US, you could be mining in Paraguay, Uruguay, Latin America, wherever. There are tons of locations. How do you, with your limited capital resources to actually invest in a property and a limited amount of time, select the best sites to actually operate at?
There's a lot of questions there. Loaded. So as a big industrial miner, if you're going to be growing and everything, yes, you do. And you really touched on something there. The globe really is your market. You can operate wherever you want to operate. So we start by first looking at geopolitical and economic risk associated with owning property. You have to be very careful there. And if you're going to operate somewhere where you're not going to own the property, you need to figure out exactly what risk exposure you have. If you're providing machines and technicians and engineering and software, or if you're providing capital for infrastructure, who's going to own that infrastructure? Who can turn that infrastructure off? Is your power generation because some random law gives you some benefit that wasn't designed for Bitcoin mining, but was designed for everybody else, and you're just taking advantage of that situation? That's what happened, by the way, in like your Norway and Sweden. There was some laws there that kind of encouraged renewable energy use, but Bitcoin miners come in and artificially lowered the rate. So people come in and started mining there because the rate was artificially lowered, not by economic means, but by political means. And you can't do that. You can't make your decision to operate a facility because pricing is artificially held low for a reason you can't control. So you need to make sure that if you're going to a country, that the economics work without a political influence of some kind, meaning you're not taking advantage of a law that's been created to lower the price of energy, or a government subsidizing the price of energy, because that can change on you very quickly. Second, I would make sure that if you're going somewhere, you want to make sure you're wanted. Not that you're sneaking in the back door, but you go in the front door. Everyone has eyes wide open. They understand the economic benefit you bring to the table. You understand the economic benefit they bring to the table. But going back to profitability and optimization, if we look back over Bitcoin mining, and this is an important point, if we look back over Bitcoin mining over the previous halving event in the past couple of years, past 4 or 5 years, the winner was supply side. Who could get to the equipment the fastest? Who could refresh their equipment the fastest? And who had access to parts, and who had access to transformers? Who had access to switchgear? Who had access to all these things you needed to mine? And in the last cycle, the silicone that the Bitcoin mining industry used was behind the rest of the world. So there was some big leaps in the silicone chips. When we moved from a 56 nanometer chip to a 28 nanometer chip to a 14 nanometer chip, we were really making the other machines obsolete in a very quick period of time, like 2 or 3 years. So you, as a Bitcoin miner, you had to buy your machine, mine with it, pay for it, and make your profit all in a 3-year period, a 4-year period, because you knew that the next chip was going to come out and was going to obsolete your old stuff. We're going into the next cycle of Bitcoin mining where supply chain is not going to win, but engineering is going to win. And that is because the chips that the Bitcoin mining industry is using has now caught up to the rest of the world. The S19 and the equivalent micro BT product, and I talked about the Bitmain product because at Core we've been a Bitmain house for this past cycle. It was a 7 nanometer chip. The XP product and the new products from micro BT right now are a 5 nanometer chip. Well, guess what? Apple's at the 3, but Apple's the only people buying the 3 right now. Everybody else is at the 5. So Bitcoin mining, the whole industry has caught up to the rest of the world when it comes to silicon. What that means, Will, is that you're not going to obsolete your old fleet. You might have one that's more efficient, and it might be better. Your fleet that's at 21.5 joules might be better than your fleet that's at 29.5 joules, but not that much better. It'll make a real point when Bitcoin's at 16,000, but when Bitcoin's at 30 or 40 or 50,000, the difference between power costs, that extra $12 a month it costs to run the one machine versus the other, is not a big deal. And I say all that to say, people made decisions in the last cycle where they knew machines were going to have to be replaced every 3 years. In this next cycle, that's not the case. Machines aren't going to be replaced, but there is a scale of efficiency and a scale of profitability. And for those of us that lived through it, either through whatever means we lived through it, the down cycle of 22, when power went up and Bitcoin went down, they understand just how important it is to be optimized for that down cycle, right? So your optimization on that down cycle, and you need to be optimized so that you can, at a minimum, maintain your operations. Even if you're curtailing your entire fleet, you got to be able to maintain your economic base to get through the down cycle so you're ready when the up cycle happens again. So I think in the past, we've looked at optimizing machines and being able to replace machines. And I think in the future, it's going to be, how do we optimize our overall fleet? How do we make it more efficient? How do we use software to be more efficient? How do we make sure our technicians and our repairs on site are more efficient? So I think all that's part of the profitability piece. And I think going forward, you need to be profitable, making money when you can in the bull market. But I think everyone's going to be paying attention to what happens in the bear market to make sure they can survive.
Well said. You actually tied in one piece that I didn't even mention, which is that hardware side. And to dive into the hardware side a little bit more, I think if you go back in time and you look at how these chips have evolved, it's very similar to what you'd imagine in early industry. In an early industry, you're seeing a lot of innovation. And the big innovation that I think you were touching on there is that you had the nanometer chips going down and down and down, becoming more and more efficient, where I'm not even sure what the nanometer size was on the early chips or even the S19. But right now, these newer models are 5, 7 nanometer, which is far more efficient. You can get a far better hash rate, far better efficiency from these newer chips than the older chips. So if you were a miner, you were constantly having to cycle out, get new hardware. And now we're at a point where it seems like you're also of the belief that the chips are not going to have these big leaps in efficiency. And so a big component comes down to how well you can run them, how well you can maintain them, and not necessarily having to plan to completely get rid of your fleet whenever new machines come out. Am I restating that correctly?
Yeah. So basically, when you're looking at machines or your fleet, you're looking at a joules per terahash. Or think of that watts per terahash. And that's how efficient your machine is or how efficient your fleet is. So that's how many terahashes you're mining and how much power is it taking to do that. When the 7 nanometer chip, which first came out on Bitmain product in the 17, it was in the mid 40s as far as joules per terahash. You can now get a 7 nanometer Bitmain product at 29.5 joules per terahash. So that 7 nanometer moved from mid 40s to 29 joules and a half per terahash. And again, I'm just talking about the Bitmain products. MicroBT has the same kind of products, and they're an excellent engineering company. They do great products. But on the 5 nanometer chip, the XP for Bitmain is 21.5 joules a terahash. So we expect that the 5 nanometer chip, there'll be some products that move that 5 nanometer chip into the teens. We expect that eventually Bitcoin mining will move to a 3 nanometer chip, but that's a ways off, Will, because your iPhone you have in your pocket right now Apple's the only company on the planet right now buying the 3 nanometer chip because they bought them all. Because it makes a difference in these little devices, because everyone pays, they complain about the power usage on the devices, and the smaller chips use less power for the same amount of processing. So Apple's buying all the 3 nanometer chip, which means the rest of the world's buying the 5, which means you can still get 7s if you're a Bitcoin mining company trying to make machines. The whole world, though, will move forward. So next year, starting in 24, Apple will still be buying 3s, but there'll be more 3s available for other people. And then because that 3s, other people move to 3s, Bitcoin mining will move into the 5s, and we'll all have that cycle. But these machines, again, let me emphasize this, are not going to obsolete the old machines. The 19 pretty much bricked the 9 as far as Bitmain models go, because that 14 nanometer chip, when that 7 nanometer chip got down into the 20s, it really made those other machines obsolete. Now, if Bitcoin goes back up to 60 or 70 or 80, we'll see some 9s come back on again just because they are profitable. But if you have very expensive infrastructure like we do at Core, you're not going to waste that infrastructure on inefficient machines. You're going to put the most efficient machines in that infrastructure, because that infrastructure is expensive, and you got to get paid back, not just for your machine, but you got to get paid back for your infrastructure. So as we move forward, there's going to be less cycles on machines, but people are going to be paying more attention to, making their machines more efficient, making their infrastructure more efficient, using software not associated with machines to make their overall fleet more efficient. And all those things are for optimization. And when I say optimization, I really mean profitability. All those things are going to be for profitability.
It's really interesting when you look at the different ways that the price affects the mining industry and the cycles of hardware. You brought it up where if Bitcoin goes and moons, then all of a sudden these S9s that were looked at as scrap metal are now all of a sudden profitable once again if you bring them online, and you see those go to the cheapest parts of the world where they'll be thrown in these dinky setups and will just run and still be profitable until Bitcoin goes through its cycle, and then they're taken offline again. On the operations side, I'm curious, how are you guys looking at liquid cooling or immersion cooling systems? This is something that there's been a lot of talk about immersion systems for a number of years now. It's not like this is absolutely new technology when it comes to Bitcoin mining. There are many different types of systems, but when you speak with these operators of these immersion cooled systems, they always seem to say really good things about them, because they report having better efficiency in terms of being able to maintain the longevity of a chip. So if you're running a very expensive chip, you want to make sure that it's being able to run for a long time. And then I've also talked with operators who are saying that these systems have allowed them to actually overclock and get more hash rate from machines and have it not completely destroy the machine. I myself am nowhere near as experienced or an expert when it comes to everything operations. So I'm very curious to hear your take on the evolution of these engineering mining designs and what your thoughts are on immersion systems.
So, immersion using a mineral oil type system or water cooled systems, they're not new to data centers at all. Your traditional data centers have been using those systems for decades now. Your overall goal is to remove heat from the chip. And you can do that by, in a water cooled system, cold water, just think of it this way, a little cap goes on a sealed cap. For a water cooled system, a sealed cap goes on the chip, and cold water is run around the cap so it cools off the chip. In an air cooled system, air is blowed across the chip, so it moves the heat across the chip. In a liquid immersion system, the chip is actually sitting in a dielectric fluid that doesn't conduct electricity, and the liquid itself moves the heat off the chip. The liquid is taken outside the system, cooled back off, the heat released, and then that cold liquid is brought back in again. So whenever you're trying to run a Bitcoin mining operation, it's all, and the processing itself heats up the chip, and it's all about cooling that chip off. Now, when you decide if you want to go water cooled, oil cooled, dielectric fluid cooled, which is an oil base, oil cooled or air cooled, it's all about capital. It's all about efficiency of the chip, and it's all about chip design. When the more heat you can move off the chip, the higher you can run the chip and the more processing power you can get out of the chip. So that's why immersion was developed in the traditional world, was because they wanted to get more processing power out of the chip. The interesting thing, though, you need to think about is that dielectric fluid, it degrades components of a machine differently over time. In the traditional data center world, a lot of the immersion system and the machine that it's going to go into are all designed at the same time. And every little piece is tested with that oil. So what you have to do as a Bitcoin miner is be very careful on the formula for the oil that you're going to immerse your machine in, because if that machine hasn't been tested for that oil and every component tested for that oil, you could actually start eroding your machine at a different time frame. So why that's important is your machine manufacturers might start out using one supplier for components, but then change halfway through because that supplier runs out. So they might change. So when you're doing a design that is liquid immersion cooled, you want to be very careful and make sure you're testing all your components, and you want to be careful to know if your components change or not. Now, if we go back a cycle and chipsets are scarce, a reason to go to immersion is because what you just said is you can overclock the machine. You can take a chip that's supposed to do 100 terahashes, or let's say one chip was supposed to do 1 terahash. You could take that chip up to maybe 1.5 terahashes because, again, you're moving the heat off of it. So when you're a Bitcoin miner and you're trying to decide between air-cooled, water-cooled, or immersion-cooled, there's a lot of inputs for you. You got to decide what's the price of the chip and what's the price of your infrastructure. So those are two CapEx components. When you're a Bitcoin miner, you have CapEx for the machine, CapEx for your infrastructure, and OpEx equals a Bitcoin. And those are your three components. How much did I pay for my facility? How much did I pay for the chips? And how much do I pay to operate the chips? And immersion is two of those pieces there, and it affects the third. So our water cooled, our air cooled. So you have different CapEx for immersion than you do for air cooled, than you do for water cooled. You have machine life that could be affected both positively and negatively. A machine that's designed for air cooled that's put into immersion might not last as long because you degrade the parts. Conversely, a machine that's designed for immersion might last a much longer period of time because it's not exposed to heat and dust like an air-cooled situation. And a water-cooled, if you have the correct components and they don't leak and all that kind of stuff, can actually be an elegant solution because in a water-cooled situation, you're basically encapsulating the chip only, and you're not immersing the whole device into fluid. Of course, not water. You electrocute a bunch of people, but because you're not immersing the whole device, you don't have to worry about eroding a device like you do in immersion. Again, though, all those have their own engineering pieces, their own design pieces, their own CapEx, and their own life of the machine and their own OpEx. So I can't tell you as I sit here today, Will, if I'm pro air cooled or pro liquid cooled or pro water cooled. When I say liquid, I mean oil, because it's very situationally dependent. It's dependent on the machines you're going to be mining with. It depends on your environment. Marble, North Carolina, I would never convert that to an immersion facility, but that's because that little valley is at 70 degrees most of the time. It's a perfect air cooled environment. We use filter walls, and the air cooled works just great there. If I were in a desert somewhere and I was trying to operate, then liquid immersion or water cooled is going to work great because you have dust and you have heat. And when you input air is really high, immersion becomes a great opportunity for you. Or water cool becomes a great opportunity for you because if your input air is really hot, that has a problem. Same thing if it's really cold, by the way. The cold can be just as bad for chips as the hot. Most people, when you get into it, you understand the cold can crack a chip at the very beginning. So the cold can create instantaneous death for a machine. Heat is like cancer. It's a slow death for a machine because you can actually over time, burn the machine up. But both extreme temperatures are bad for a chip. And oil cooled or liquid immersion cooled can address that heat, which can extend the life of the machine. I think I gave a really long answer to a short question there.
No, I love that answer. I actually have a follow-up question on that. What do you think is that upper bound in terms of temperature for when you might want to start exploring immersion? And then what's that lower bound for when it gets very cold and you might just be cracking chips? Okay,
that's a loaded question, and there'll probably be 75 engineers tell me I'm wrong here. But a general rule of thumb is if your input air is mostly above 90 degrees Fahrenheit, then you probably should not be looking at air cooled at all. You should be looking at liquid immersion cooled or water cooled. If your input air is mostly, in the 70s, then hey, you got to do the math to see if it's really worth it. On the low side, in our North Dakota facility, it gets down to -20, -30, -40 Fahrenheit. There's a problem when that happens, though. These machines produce heat in those kind of cold environments. You have to recycle the heat because you have to keep the heats warm. And you also have to be careful in turning the machines on. You have to preheat a machine, because if you turn a machine on and it's frozen, you will immediately crack the chip and it's broken forever. So when you operate in a cold environment, our friends north of the wall in Canada have this experience here in North America. Norway, Sweden, your Scandinavian countries over in Europe have this. Our friends in Russia that mine have this. But when you operate in those cold environments, you have to preheat the area before you turn the machines on, and then you have to recycle your heat over and over again. So if you're below freezing at all, you need to not just turn the machine on. You need to talk to somebody who knows what they're doing. So the thing is, so think about this, like 40 degrees to 70 or 80 degrees. If that's your input air, you probably want to say, you know what, I'm just gonna do air cool because it's really simple. But if you're outside those boundaries, you need to talk to somebody and not just do it, because you will either cook your machine or freeze your machine if you go outside of those bounds. But by the way, 40 degrees to 80 degrees, or 90 degrees, that's a pretty wide band. That's a lot of America.
Yeah, I think most places fit within that band. So what's next for Core? I know that you guys have you've operated massive industrial scale facilities. You guys obviously have a very good understanding of how these systems work. What are some of it could be technology advancements, anything. What are you excited about of what you guys are working on?
So a couple things. First, I'm excited about, we're going to start looking at our fleet refresh and fleet optimization over the next couple of years, moving into machines that are more efficient on a machine level. I'm excited about our software, our Minder software that we use as our fleet management software. We've been using it now for 4 or 5 years. We've got a lot of data that most, quite frankly, I'm not sure anyone else in the world has. In the last cycle, we mined 200,000 or 300,000 of the last cycle's machines. This cycle, we're mining 200,000 or 300,000 of this cycle's machines. And we have all that data from 7 or 8 facilities. So we have data from different facilities at different temperatures, different environments, a lot of different machine types. And all that goes into our fleet management software. And we use that fleet management software to optimize individual data centers. And by optimizing, I mean, we make it to where our data center technicians, we try to take those things that if software can do it with a soft reboot, it does it. Or if a machine needs to be touched by somebody, we try to make it the most efficient possible, so that when a technician is rolled out to a building, he or she knows, okay, I need to take 3 fans with me. I need to take a hashboard with me. I need to take a PSU with me, whatever the case may be. We try to make our software work for our data center technicians. Matter of fact, if you ask me who our client is for our Minder software, it's our DCTs. So we design our software to try to make our DCTs the most efficient possible, so that their day is spent mainly keeping our machines up and hashing. And that's a metric we look at Core every day, is kind of our up and hashing number. What's our efficiency on our up and hashing number? Now, of course, we all love to look at our Twitter feed every day and see how many Bitcoin we mined. I personally look at not just our Bitcoin that Core mines, but Bitcoin at our facilities. So that's why I told you last year we mined 26,000, because if you want to look at our fleet, I need to look and see, okay, not just Core's machines, but also the machines we manage. So we try to make it so that the machines we manage are the most efficient possible, and the most profitable. We're only profitable if our clients are profitable. So even those clients that host with us, we want them to be profitable, because if they're not profitable, they can't pay their bills. And we're a bill, so we want them to pay us. So I guess I'm looking forward to what our next step of fleet optimization looks like, what our next machine is going to look like in the future. I'm looking forward to some of the software we have rolling out. And quite frankly, I'm looking forward to, we've got right now, I just checked, we have 799 megawatts of up facilities right now. If we finish building out the places that we've already started, we're going to have like 1.1 gigs. We're going to have 1,100 megawatts of facilities. And I can't tell you if we're going to ever need more than that. We might, but if we're able to move our overall fleet from 30 joules of terahash down to 20 joules of terahash, that means I've automatically moved us up from 20 exahash to 30 exahash. I've already got a 30% improvement just by changing the efficiency of our existing facilities. And that's important because at Core, our facilities are expensive. We build facilities that try to have as few hands-on as possible. So our facilities are expensive and our uptime is very high. So we actually target facilities are expensive. So if we don't have to build more facilities, but we can increase our overall exahash. That goes back to profitability and that kind of optimization we talked about. So think about if you already own a gig of facilities and you have the next round of fleet optimization happening, you're not actually spending any money on 1,000 megawatts of facilities. You're only buying new machines. You can become a very efficient miner in that kind of world. So
that's just a tremendous amount of power. That's incredible. You guys, once you're fully built out with what you're working on now, you'll be over a gig.
We'll be if we just take our sites we're currently operating at now, not building, operating at. We just finished building out the sites we're operating at. Yeah, we'll be at 1.12. I'd love to get to 1.21 because that'd be great. We'd have like a Back to the Future theme, but we'll be like 1.12 gigawatts, I think.
Wow. So final question. A lot of people listening, they've learned a ton in this conversation. I've learned a ton. You're one of the most knowledgeable people in the entire mining industry. If there are any key takeaways and predictions that you can share, I'd love to hear them. I know a lot of people like hearing price predictions, but those are always tough. So really any type of prediction that you feel comfortable making on Bitcoin mining, I'd love to hear it.
So I have no price predictions. That's on Bitcoin itself. I do think Bitcoin, though, is really going to be coming into its own as far as adoption goes. I'm a fan of crypto, but I'm a big fan of Bitcoin. I think Bitcoin has a place in the world for banking the unbanked. I think it has a place in the world for wealth creation. And I don't mean you or I that live here in America or folks live in North America or Europe, but much of the world has issues getting access to bank accounts and access to a place to store their wealth where someone else can't take it from them. So I think the world in general is going to start seeing more and more adoption of Bitcoin as a place to hold wealth. And I don't necessarily mean paying for coffee with it, but I mean like digital gold. I do think there needs to be some sidearms attached to Bitcoin, and it might be through a smart contracts with Ethereum as far as payment processing goes. So I think we're going to see. So I think Bitcoin itself is going to continue its adoption as far as wealth creation and wealth holding for people. I think other coins that are going to be tied to Bitcoin are going to be associated with payment processing and improve the payment processing system. Think how easy Venmo is to use. For Bitcoin mining itself, I think our industry is going to mature, and it still needs some maturing to happen. What was the last cycle? We didn't have any big public U.S. companies that were Bitcoin miners, so nothing was transparent. Your large miners in China, they weren't sharing things with you. Your large private miners in all parts of the world, no one was sharing anything because you don't need to as a private company. This cycle, we have a lot of public companies that are Bitcoin miners. So a lot of information is being shared, and that's important because it's going to improve us as an industry. Because when you're sharing information, you have peer groups to say, "Oh, am I as efficient as are those operators over there?" So I think our industry is going to mature. We're going to become more efficient as an industry. I think that's going to be good for Bitcoin. We do have some things, political things you talked about, the New York Times piece, the legislation in Texas, Biden's possible tax on Bitcoin mining. We have some education to do. And I really would love to see the power and utility industry to lean in on some of that, because those folks can come at this from an unbiased perspective and actually help really educate folks. I would love for the DOE, Department of Energy engineers, to go sit down at the White House and say, "Hey, wait a minute. Here's some attributes of Bitcoin mining that I need you guys to think about," because that's not happening right now. So I do think, some of that needs to happen. I think it will. But going back, I think our industry is going to mature, become more efficient. I think the inefficient players are going to have to find something else to do. I think engineering going forward is going to be more important than supply side and speed to market. Although speed to market, Core won the last round, speed to market, because we got out ahead by luck or happenstance. We got out ahead of others as far as building large scale facilities. But I think that's over now. I think engineering is going to win out, and I would take a 100 megawatt engineered facility that's really optimized over a 200 megawatt facility that's not optimized all day long. And just the price of power and the price of operations should tell you that. I'd rather have a highly optimized 100 megawatt facility that's very profitable than a 200 megawatt facility that's not. And again, if you ask me that, and Bitcoin's 100,000, I'd probably tell you a different answer, because I want that 200 megawatts just running as fast as you can. But if you want to survive for the long run, you really need to have that optimized 100 megawatts. So I think your Bitcoin miners are going to be looking at that for the long run as public companies with a long-term perspective. I think it's going to be very important, even though a lot of people like to think public companies are only thinking about their quarterly, their next quarter's announcements, but that hasn't seemed to be the case in Bitcoin mining. Bitcoin miners think way beyond that. We're looking at things in the halving events kind of stuff, and in cycles of silicon chips. So I think all that's going to see an improvement in the mining space. Again, long answer to a short question.
Russell, thank you so much. This has been absolutely incredible.
All right. Thanks, Will.
Also, as a quick thank you for listening to this channel, we have a link in the description for the viewers that will give you access to Saz Mining's team and any other promotions that Saz Mining is running. So if you want to get exposure to Bitcoin in the best way possible and at a discount through Bitcoin mining, then make sure you click on that link in the description. You'll get the opportunity through Saz Mining. Back to the show. So that was it for today's video. On this channel, we upload content around Bitcoin and Bitcoin mining. So if that's of interest to you, subscribe. Click on this video right here. That's it for me today. I'll see you next time.